So it is the first Friday of the school year. Are you all excited for the weekend? All right. So just a reminder about headphones every single day. If I'm talking up here, I do want y'all to focus and not headphones in our ears. Cool. Okay. So let's check this out. We're going to go over any questions you might have on the assignment. So let's look at this. Did y'all have any questions on this assignment? It could be the hardest problem, and I'll go over it. 7? All right, look at number 7. Okay, 9 minus 29. So yesterday we learned that the rule is you want to look at these signs. Now, do these signs match, or are they different? They're different. This is negative, this is positive. So when they do not match, when they're different, you subtract big minus little. So 29 and 9, let's do 29 minus 9, what do we get? 20. And which one's bigger, the 9 or the 29? 29, which is negative, so your answer needs to be negative 20. Okay, that's the rule. That's the kind of the shortcuts we talked about yesterday, the notes. So negative 20 is what you should put on your number line. Okay, so you put a negative 20. You can put other numbers on here. But you want to put a big old dot at negative 20. Cool? All right. What other questions do you have on this assignment from yesterday? Hey. Did y'all have any questions on the PEMDAS? All right. So, sounds like y'all are done, so we can go ahead and pick that up, and then we're going to do the notes for today. Cool? In the future, if you have questions, please raise your voice, because I'm here to help y'all, but sounds like y'all got it. All right. Thank you. And then when you're done with that, you can turn it in.
Do I sign it for my mom?
You just sign it. It doesn't need to be signed. Just whatever you got. Sure. Well, thank you. Yesterday's. Cool. Okay. Even if you didn't finish, I'll take it. That way you got something for today. All this, as much as you know. Okay. Thank you very much. Thank you. Thank you very much. Thank you very much. Thank you. Awesome. Now, we are going to move on to the notes. Did everybody grab it on the way in? The notes sheet, I should say. All right.
Guys, it's very important. Make sure you pay attention today and make sure you fill this out.
All right, combining like terms. Now, I don't know if any of y'all have had any experience or exposure to algebra in your last year's class, okay? But this is a very important part of algebra, okay? To even solve an equation, before you can even do that, you have to be able to simplify what we call an expression. And one of the main things you need to know how to do is combine like terms. So we're going to start off with key vocabulary. What are the things that you need to know? So the first one, a blank is a letter that used to represent one or more numbers. That's supposed to be 1. So go ahead, that's a typo, 1 or more numbers. So what do you think we call this? So this is called a variable, okay? It's a letter. Now, y'all ever think it's weird that we have letters in math? Because math's supposed to be numbers, right? But technically that letter stands for a number that's not defined yet. So go ahead and write the word variable right here.
So in the example 3c, c is the variable, okay? 3 times c C is the variable. Also 4x, I know you guys are used to seeing x a lot. X is the variable. You may want to put the examples down as
So
well.
3C or 4x, these
Any letter
letters
that you
are variables.
see in math is probably going to be a variable, okay? Especially if there's a number next to it.
All right, and the second one, a blank is a part of an expression that is added to or subtracted from, go ahead and underline those, another part. So the parts of an expression are called terms. So it's a term, and the other part is also called a term. Please notice that they're separated by plus or minus.
6 minus 4 is an example, or 2y plus 5y.
All right, on to that. So numbers can be terms, like the number 5. Numbers with variables can be terms. 6y. Numbers with variables with exponents, 7x squared. Those are all different types of terms, and it doesn't even matter if they're negative as well. Question?
What's the difference between a term and an equation?
Okay, so a term is like a little piece.
Here's an equation right here. 2x minus 3 equals 4. Whenever you see an equal sign, there's going to be an equation. Okay?
Yeah, so equation is the whole thing. Terms are the pieces of it.
An expression would be this without the equal sign. So random things, 2x plus 3 minus 5x, that's an expression because you're not trying to find out anything. You're not making any. In this, I could solve this to find what x is. We're going to worry about that. Okay.
Exactly. So yeah, equations have expressions on both sides of the equal sign. Is another way to think of it too. Now the next one, a blank is a number part of a term with a variable part. Okay. Basically, when you have a number in front of your variable, it's called a coefficient. Coefficient.
Example would be 6a here. The 6 is the coefficient. That's a number in front of the variable. Another example would be 4b squared. The 4 in front of the b.
All right, so those numbers in front of the variables are our coefficients. Now this next one, it's a blank. It's a term with a number part but no variable. This is a constant. I know it looks like there's supposed to be 2 blanks, but constant. Okay.
You just want to put it.
Yeah, a constant. Yeah.
If you want to do like a plus 6, the constant is the 6. Okay. If you want to do 7 minus x, the constant is 7.
Just the numbers by themselves. Now, usually your constants will be at the end of a expression or an equation. Yeah, so blank blank are terms that have the same variable parts, and the variable and the exponent must be the same for both terms. Okay, these are called like terms, and this is what we're learning today: what to do with like terms. They have the same variable parts. That's the big underline right there. That's why it's bold and capitalized. Okay.
So an example of like terms would be something like 2x plus 4x. They both have x's in them. You can put 2x and 4x together. It's the same thing. Okay, another example would be like 3y squared plus 2y squared. They both have y squared. You can put them together.
Same variables, like terms. Very good. So make sure you have that down, and we'll test your knowledge below.
Not many of you. Everyone gets to participate. This is going to be awesome.
All right, I'm going to scroll down. All right, here we go. Examples. So we're going to tell, are these like terms or not? Okay. So start with the first one, 4x and 3x. Do you think those are like terms, and why or why not?
Yeah.
Okay.
They both have one x, just x. So you could put them together. This is the same thing.
They are like.
So they are like terms.
Because
4x
we have
plus
the same variable.
You can put them together.
4x and 3x have the same x. Same variable. You could put they both have x or they have the same variable. I think I've changed it throughout the day.
So I could put 4x and 3x, that would make 7x. I could put them together. Okay, they go together.
All right, 5xy and negative 8xy. So do you think these are like terms?
Do they have the same part?
Okay, so that negative is a little
Don't worry
different.
about the negative.
Mm-hmm.
No one cares about that. So never let that decide whether they're like terms.
Yeah.
Then yes.
Always look after the number. So the x and the y
variables.
are
Are
the
the
same.
variables the same? Do they both have exactly x, y?
Mm-hmm.
Yes, you can put them together.
Mm-hmm. So yes, they are like terms. After the coefficient, the variables are the same. So the same variables on this one. Okay. All right. So 3m squared and negative 6m squared. Like terms or not? I hear yes. Anybody think no? I think yes. They are like terms. Very good. The m matches and the squared matches. Okay, they have to be the same.
You couldn't have m squared and m. Those would not match together. It has to be m squared and m squared.
Same variables, technically. On this next one, 4 and negative 2. Let's think above earlier in this page. What do you call 4 if it's just a number by itself? Well, I mean, what type of? You're right. What do you call it? There's a vocab term we use.
What was that word we called them? It's just a number.
Constant. Yeah. So 4 is a constant. Negative 2, also a constant. So, what do y'all think? Like terms or no? No. I hear no. No.
Could we put 4 and negative 2 together?
Yes. Yeah. So after the number, there is no variable, and since they both do not have a variable, they are like terms. Okay, they are combinable, like we just said here. So 4n minus 2 are like terms. So same constant. Because they're both constants, you can combine them, right? X and 2. You sure? Are you sure? Ooh, a wager. So let's think about it. After the numbers, do they match?
No.
X, no X?
No.
So no, okay? You're right.
Has to be the same.
I have to also
And the variables
make you doubt yourself
exactly
sometimes.
the same,
Make sure
or
you're
they
sure.
both have to have no variable.
So 5x and 2 is not like terms. If I can write not, okay? Variables are different. I got room here. Okay, what about 4x and 3y? Nope. Okay, so x and y don't match. That's good. It's not. Yeah, different. I just trailed off a different. And same thing here. I'm going to get a little lazy, unfortunately, and just draw an arrow. So variables are different. X and y are not the same. They don't match. They're not like terms. And then on the last one, 4x and 3x squared. 4x and 3x squared. They both have an x. Are they like terms?
No.
Okay.
Because of the
You had it.
yeah, exponent.
Okay, good. So the exponents need to match. They don't. So we're going to say not.
And that part always messed me up when I was your age. I always wanted to put them together. So I saw x and x squared. I thought I could put them together. You cannot. They're different.
Mm-hmm. All right, so everyone should have that down. So hopefully you have an idea of what like terms are, and then we do something with like terms, right, as it implies at the top. So let's go ahead and look at the bottom part. I'm going to move this up. So let's identify the parts of an expression. So on number 1, terms. How many terms do we have in the expression on number 1? So we do have 2 types of terms.
Two types. But how many total terms do we have? What does they look right now?
Here's one term. Here's another term. Here's another term. 3 terms. Remember, terms are separated by plus or minus. Okay, plus and minus is like a space between words or something. Okay, so there are 3 terms separated by plus or minus. How many like terms are there? So we kind of already said that. There's x's that can combine, and then the constant is a different type of term. Again, let me know if you can't read what I write. Sorry about that. It's hard to write on this laptop. Coefficients. So remembering what a coefficient is, who can tell me what the very first coefficient is? Right here. Okay.
What's in front of it? I know you don't see it, but what's really there?
A one?
A 1.
Mm-hmm.
Okay, you guys don't see a 1 there. Whenever you see a variable by itself, there is a 1 there.
So never include the x when we ask about what's the coefficient. So leave the x alone, the negative sign with the implied 1. So -1 is our coefficient, and then what's my other coefficient here? 2. Okay. That other number doesn't have a variable, so it's not a coefficient. We're going to leave that alone. And then answer the last part. What's the constant terms that we have here?
Constant's just the one number by itself.
8.
8. Okay, so 8. That's it. Cool. We're going to do the very same thing on number 2. So how many terms are on number 2? Okay, so we have 1 term, 2 term, 3 term, 4 term. So 4 terms. And what type of like terms do we have? We have some x's we can combine that are like terms, and then we have
What do we call just the numbers by themselves? Coefficient, constant.
constants. Very good. So we got variable x and constants. Write this down. So what are my coefficients here? Not 5.
Remember, the coefficient comes right before the variable. It has to be attached to the variable. 2 and what? 8. 2 and 8.
2 and 8 works out. They're in front of the variables. And then what are the constants that do not have variables? So don't forget the sign that goes with the 5.
So what type of 5 is it?
-5 and -3. Cool. All right, so we kind of broke down some expressions, dissected it a little bit. You can flip that over. All right, so how do we combine like terms? So combining like terms is the process of adding or subtracting terms that have the same variable parts. Okay. So again, once you know what's like, then you can combine their coefficients together. Okay. You add or subtract them, the number part in front of the variable, and then you keep the common variable parts. This is really weirdly worded. Sorry. So if the variable parts are not the same, you cannot combine those terms. So please, if you can't combine them, do not combine them. Very important rule. So let's get to it. Let's do 1 through 6. All ready? Number 1. What is m plus 3m? And I might call on people who don't answer. So
remember
answer the easy one.
Okay, there's something in front of that answer, even though you don't see it. It's always there.
Okay, so yeah, that 1m, and I highly suggest drawing it every time. It'll help you. Okay, yeah, 1m plus 3m. Add those coefficients. You just got 4m. Okay, right? Number 2. What do we got here? 4r plus negative 3r. So, y'all know plus a negative number is like subtraction. So 4 minus 3 should give you what? 1r, and 1r, we do write it as just straight up r, which is great. So, okay. So,
Is it positive or negative?
Well, when you have a positive and a negative, it's negative. Okay? A positive and a negative like that, just keep the negative. So it's just basically 4 minus 3r.
right. Adding a negative, yes, adding a negative number is like a subtraction sign. Another way to say it. So 4 minus 3, 1, which is the same thing as just r. Number 3, what do y'all think? It's minus though, right? You can do it. So 8w minus 1w. 7w, right? 8 minus 1, okay? I appreciate the effort. Now, number 4, now this gets a little more complicated looking, but you can still just combine things that are the same. So I suggest circling or underlining or something indicating what is like terms.
Put together in number 4. 7y and negative 5y. Those are two things you can put together. 7y, negative 5y. Those are like terms. They go together. So now we just have to do 7 minus 5.
And what do we get?
Take away 5.
2.
All right, yeah, 7y minus 5y gives us 2y.
Make sure you have that y there.
And then,
What are the other parts we can put together?
what are these called? So those constants, 9 minus 2 gives us 7, so plus 7. So 2y plus 7 is our final expression when we combined like
Can
terms.
we put the 2y and 7 together? No, we're done. We cannot combine them. They are not like terms.
All right, let's see if we don't get tricked on number 5. What is 8y plus 2? That's what I said. I'm kidding. You're right. 8y plus 2 is 8y plus 2, okay? Don't force it, okay? It's not 10. It's not 10y, okay? You can only add them if they have the same exact exponent. So, yeah, 8y plus 2. All right, number 6. What can I combine? Okay, you can combine. Now, let's go alphabetical order. Start with the x's. What are my 2 x's? 5x plus 3x. Okay, usually you write these expressions in alphabetical order. That's why we're doing it that way. But what is 5x plus 3x? Okay, 8x, and then our y's. What y is this?
Don't just say 4y. It's not 4y. Negative 4y.
Always keep the sign with the number, right? So negative 4y plus 6y. What's negative 4 plus 6? 2, okay? So remember, it takes the sign of the bigger one, which is 6. So it's a positive 2 plus 2y, okay? Okay, so we've gone through what these vocab words are, what are like terms, how to combine like terms. It only gets more voluminous. The only thing it does is get more variables, longer expressions, but it's the same exact idea when you're doing this.
Once you learn how to do it, it's really the same thing over and over again. You have to practice.
All right, so that's it for the notes.
Does anyone have any questions about it? And there's only a few of you in here, like, you should be able to learn if you want. Anyone have a question?
All right. So hold on to always hold on to your notes. Okay, keep them in your backpack folder, right? Don't lose them. And on Monday we're gonna do an assignment based on it. We're gonna hold off on that. Y'all got some extra time. Y'all earned it. So.